That's number 2.
Then it's supposed to be a micro?
All right.
Now, she'd already planned to leave the House of Representatives. She was, of course, going to run for governor in the state of New York, but she dropped out of the governor's race after she got a Republican challenger primary. You know, didn't want to have to run against the person.
Now we're back.
Oh, it's a solid. It's a solid.
My gut tells me this is not the right thing. This is not the right sort of array of things lining up, which is so typical to do let alone primary and everything.
Last try.
Think of it.
Good. All right.
What's that? We can have. That's nice.
I just wanted to
Thank you.
Good morning and welcome to the first mall users group. And it is a pleasure to welcome you to our first gathering to how do I change the slides here? I did and I didn't do. Okay. So this is the outline for today. So we're going to have an introduction, gonna talk about the sustainability and governance of the library, the updates in MATLAB, Octave, and C++. Then we're gonna show a couple of example applications. One for the general curvilinear coast and ocean model, and the other one is a modeling of nonlinear dispersive wave. And then we do a summary of the model peer review, and then we're gonna talk about the current and future model language implementations. And finally, we're gonna talk about the strategic plan for the future, and we're gonna open the floor for questions, comments, etc. Okay, so this is the agenda. And basically, I'm going to talk to you about the introduction of the MOL library, what is the purpose of the meeting, what we learned from our interviews, and invited you to the MOL tutorial that is going to be in May 12th. Okay, so basically, at least this is the way I describe the library. MOL is a building block. You can think of MOL as a building block to create computational efficient computer codes to solve complex problems using mimetic different methods. Of course, that's what is mimetic different methods. Those are basically numerical schemes which are based on mimetic difference operators to solve partial differential equations. And what are mimetic different methods? Well, these are mimetic different methods construct discrete analogs of divergence gradient operators. These discrete operators mimic, and that's the way mimetic come from, the same properties of the continuous counterparts. In general, we don't discretize the equation. What we do, we construct a discrete analog of the equation we want to solve, written in the MOL with the MOL operators. And then we decide how we're going to solve that discrete analog equation, okay? The resulting schemes are more faithful to the physics because basically, in some sense, we are creating a discrete vector calculus. And the operators, this is one thing that we like to highlight. They have this uniform order of accuracy in the interior as well as the boundary. And there is no other numerical methods, operators that have this property. Okay, so again, what are mimetic operators? They are discrete analogs of the first order invariant operators, divergence, gradient, and curl. And the starting point is that all the equations for mathematical physics can be written in terms of these operators. Right? And so these mimetic operators satisfy in the discrete sense the same properties that the continuum counterparts do. Again, mimetic method construct discrete numerical schemes based on the mimetic operators divergence, gradient, curl, and Laplacian. MOL is an open source library that implements high-order mimetic operators. It provides for you these discrete analogs, all these operators. Now, remember, this is a space. Like discrete calculus is actually something that works in space. If you want to use a time-dependent, solve a time-dependent problem, then you have to use a time discretization scheme. And these operators basically act on staggered grids, uniform, non-uniform, and curvilinear, and they satisfy local and global conservation laws. What is the purpose of the MOL users group? Well, from the beginning, we want to foster collaboration among all MOL users and developers. But also, it's an opportunity for the MOL community to come together and provide feedback on the library. We want you to take ownership of this library and contribute and help to sustain this as a growing community. It's also an opportunity for the MOL leadership team, MOLT, to share updates and current developing plans, share information about software engineering, governing, and onboarding documents.
Thank you.
Hi, I'm Tony Drummond, and one thing that, because we are having this meeting is hybrid, for those of you that are online, if you can submit your questions on the chat, we are going to monitor that. And anybody that is here in person, please raise your hand and we try to accommodate some of the questions. At the end, we are going to have an open floor where you can also submit some of the commentaries. So continued with what Professor Castillo was mentioning, in order for us to create a library that was going to be relevant for the community and that we can increase the number of users, because that also enrich the capabilities and the functionality that is in the library, in the summer of 2024, some of my colleagues did a survey. And this survey, really what we were looking at was that what is it needed to support the mall library? It's just, so we had the product that was research from the university and what needed to be added to that. We needed to see what new features that were not present in the library needed to be added, and understand what new users need to adopt mall in their applications, especially because mimetic differences compared to other kinds of differentiations that people are using to solve partial differential equations. And also, since we are building this open source software ecosystem for mall, we needed to learn from people that have been supporting these open source ecosystems and see how they interact. So the interview consisted of feedback from 65 participants, 39 users, and 26 of them were non-users and potential users of the library. The interviews were conducted, my colleagues conducted these interviews in person, and then created some tabulations. So let me show you a little bit of what the users required. And as you can see, one of the main things was based on documentation. They wanted more documentation or improve the documentation. And that sort of led, so this is sort of, I'm going to tell you the story of the mall library, like, a few years ago, where we are today. That's something that we are going to present, and then you're going to see where we are going with the library, since we have now established an OSC. So this was a real inclination that people wanted more examples, better documentation, that is part of the software ecosystem, in any way. But those are sort of like the different areas, focus areas. That was, the functionality was the other one, usability. It's always useful to have examples that people can follow, especially if you're in an area that people are familiar with. Then 5% sort of said that they wanted new features in the library that were not present. Testing, so the library contains some tests, but they wanted some sort of regression testing for that. Reliability is something that is very important, and for the ecosystem, reliability. And so we are going to tell you today what we have accomplished with that. So, and these are people that were already using the mall library. So the non-users also they wanted to new functionality, or they needed to learn more about the functionality. Documentation also was important for them. Also, they wanted to know, what support is in the community, usability, and reliability. And reliability is very important because, from the research or academic community, if people start building their codes, they just don't want mall to go away. So they want to make sure that we are thinking about that, and that also the products that we are putting out there are reliable, and that people can reliably trust and for their research. And this sort of applies also to industry, transfers to industry and people that are developing. So now, where do we start it? So the first was to build that open source ecosystem organization with two things in mind: sustainability, and we need to have some level of governance. Why? Because it's an open software ecosystem where we have many contributors, and we want to encourage that contributions, but obviously we need to have some quality control. So when creating this open source ecosystem, the organization, we focus on having four pillars for the organization. One was the community, to make sure that we understand what the community today is and what the future of that community is going to be. The next one was the how do we support, a community that is going to be developing 24/7? Because everybody sort of there are people, since it's international, it's public. We need to understand that people are going to be using the library even when most of us that are here in California are not present to do that. And have some metrics to evaluate periodically the library and think of the growth of the library. So for all that, we sort of needed to come up with some rules for the governance of the organization. So as the picture illustrates, there are several steps in any software ecosystem. For us was really to, when building this ecosystem or thinking about the ecosystem, to focus on what the community is. And the community really starts, from new library users, people that have not used MOL, advanced users, perhaps users that had been using the library for a couple of years already, the library developers, anybody that may not be a user but are the ones that are developing the functionality or proposing, and our collaborators. Collaborators are important because it's not only a good way to find out about new areas of applicability for the library, but also to engage in larger collaboration projects. And then, of course, our sponsors. And I'll talk a little bit about that at the end. So if you are thinking about the whole infrastructure, one of the things that is centered to that is so we are hosting the MOL infrastructure, software infrastructure on GitHub. And GitHub provides this continuous development and deployment, which is really suitable for this 24/7 type of development, and it's a very good way to sort of interact and have conversations, discussions about implementations. Users can report issues, what things are not working, or what things are not clear about the library. Recently, the last was the addition of the MATLAB tests runner, which, was there, but now it's fully integrated. So all these tests and the unit tests run every single time that somebody submits any new contribution to the library. And I'm sure that many of you have already seen those. And in recent weeks, there has been a lot of improvement in what goes into the library. So why do we need governance? Is because on the one side, we want to encourage everyone to contribute to MOL. And on the other one, we need to safeguard the quality and reliability of the library. And so for that, I'm going to talk a little bit about some of the components. But you can go into the MOL documentation site on Read the Docs, and then you're going to find the 6 documents. I sort of think of them like the first 3 contributed to MOL. It tells you how you can submit contributions to MOL. The code of conduct, that's for all developers, and some software design guidelines, which is one of the newest documents that we added. And then we have to the whole MOL OSC community are things more like, so you understand what the different roles are, like users, developers. Then you have the different circles that I'm going to talk about, and how the MOL OSC is organized. So all of these, again, are on the Read the Docs. And if you go sort of like on the lower part of your panel, you're going to find under community, that's where all these documents are. So there is a core team of developers, and most of them are going to be speaking today. And really our role is to make sure that there is all these different properties, that are important in the library. We can't, when we have new contributions, then if that contribution does not sort of adds, in a synergetic way to what we have, then there has to be a conversation with the contributors and see how we can make that fit into the mall framework. So the way that, apart from the mall leadership team, which meets every week and we review bugs, progress, from different contributors, exchanges, we have created this circles, and the circles is a practice for software, open source software governance. And what we want is that sort of isolate in a way, or have focus areas where anyone that is a contributor can communicate with the group that is leading that area.
Acá está el archivo.
The steering council committee, sorry, was there?
Ya, pero esto te puedo pasar, mire.
Es que vamos a ver cómo lo cumplimos. De repente observación usted.
Ya. Pero entonces vaya mirándomelo. Este es.
Sorry. Please, could you mute your microphone?
Desde el comienzo léemelo. A ver, estoy acá.
So,
Aquí estoy ya. Hasta la
the steering council.
7 y
Yes.
8. La 9 me falta. Va, firma y chequeala.
So I cannot see it from here. I lost it. I think it's.
We gotta do it on this. Let's do this. Okay,
You got it.
this one. This one's the host.
So where were we? Here. So there's different circles. One that is important is the steering council, because the steering council is not only the members from the leadership team, but we extend that to experts in the field that can provide also feedback on the future of the library and the sustainability of the library. And also we want to get potential people that can help fund the operations of the library being part of the steering committee. So you have heard a lot that our focus is the community engagement. So this is creating events like the MOG meeting to be an opportunity to get live feedback. Tutorials, short courses are organized under that. Anything that has to do with the software engineering of the library are part of the software engineering circles. And there is a lot of intersection in these circles and the people that are present in those circles. Then the last two that I talk about, anything that has to do with the mimetic operators and mimetic differences and the future of developments and additions, all that is done in the mimetic differences circle. The computational circle are really targeted to focus on application areas in computational sciences, and how do we interact or build new partnerships with them. Okay, so now we're going to give you a few updates on the mall, where we are, and then we'll go a little bit into some applications that are using mall and the future.
Okay, so I will talk, the library actually is an implementation of mimetic operators. Mimetic difference operators. So I will talk a little bit because most of you won't be, maybe are not familiar with mimetic differences. So mimetic differences approximate vector calculus spatial differential operators, usually divergence, the gradient, the curve, the Laplacian, and use them to write discrete analogs of partial differential equation models. Mimetic differences are not aiming only to the accuracy. So it's not just an analog that will actually try to discretize or approximate these continuous operators, but also aims to replicate symmetries, conserve quantities, fundamental identities, etc. Mimetic differences actually use an stagger grid. And so the input and the output of these operators live in certain points of these grids. Operators are constructed to satisfy the extended Gauss divergence theorem. So that's the way we try to construct the mimetic part once we have elementary divergence and gradient operators. Constructed that way, they are able to reproduce vector calculus identities in the discrete realm. They also, for systems of conservation law, they are able to preserve important quantities, meaning mass, momentum, and energy. And also, they have been applied successfully in many applications. The MOL library, as I said, is an implementation of mimetic difference operators. And the MOL operators are, we can divide it in 4 sets. One of them that includes the basic vector calculus operators like the gradient, divergence, Laplacian, and curl. And also there are some quadratures that are needed to satisfy the extended Gauss divergence theorem. In addition, we have mimetic interpolators, and also we have boundary operators. This is just a collection of the operators. That doesn't mean the operator doesn't have anything else. It has other functionalities and features too. But in terms of operators, these are the 4 sets. Okay, so as I mentioned, the MOL library actually has, at this point in time, 2 different implementations. One of them is C++, and the other one is Octave MATLAB. We are aware that MATLAB is not really something that we can get for free. But Octave is, let's say, an implementation of that functionality. It replicates MATLAB features without the toolboxes and certain functionalities. So the code that is implemented currently, and it will be also in the MATLAB Octave part, actually runs in Octave. And we call it MATLAB because in the US, most universities have free access, meaning students have free access. The university obviously pays for that, to the MATLAB software. Okay, what has been improved in the library? So originally we have some boundary conditional functionality that was improved to handle more types of boundaries, in particular periodic boundary conditions. And it also considers different possibilities of type of boundary conditions on different boundary parts of the domain. Also, there were accordingly added some new interpolation operators. In addition to this, we did some improvement in some of the differential operators that already existed. And there was added many examples and tests to exhibit how to use these new features. There will be, as mentioned by Professor Castillo, there will be a tutorial, a virtual tutorial on May 12th. And besides adding all this, we are aiming to improve more value in the library. For this, we are considering post-error processing, AMR, unstructured mesh. So there are a lot of things that we are planning to add, and we need help from you for this. So I finish here, and my colleague Tony will.
Okay, thank you. So I will talk, next week, we will release the version 1.2 of the library. And this will contain a lot of the new functionality that our colleague Miguel was talking about. Plus, on the C++ side, and we have sort of originally maintained the MATLAB. So MATLAB allows you to, have a MATLAB Octave would allow you to quickly prototype your codes. The C++ is really intended for, if you're a C++ user, obviously you use the mol C++, but also for scalability, and building large simulation codes, then you want to see the C++ library. So one of the things that we have been working active and is on the parity of the C++ to what the MATLAB the functionality that MATLAB has. And we are almost there when it comes to the implementation of the basic operators. In that functionality, we have them, and that's what you're going to find in version 1.2. A lot of that functionality with MATLAB and Octave implementation. We also have added the boundary conditions functionality, which also matches a lot of what was available in MATLAB, but not in C++. And now, that's and then, interpolation, high order interpolants are also implemented now in C++, which also increase the functionality. And one of the things just to help with the, keeping the quality of the library and the software quality. And that means that, we adhere or adopt a lot of the standards in software engineering. One of the things is that we have now one of the linters, the C-lang tidy implemented, which sort of help, guarantee the quality of the codes, and that's already fully implemented for the C++. So beyond the outlook, because we are going to communicate with all of you in the community about the new library update. So since this is where the library starts, we have a few minutes. I don't know if there are questions on chat or any members of the audience that have a specific. Are there? No. Okay. If not, then we'll move to the next area where are applications that are using the mol library. And yes. So no, that's a very good question. So the question is, how do we keep the parity, maintain the parity between MATLAB and Octave? And as you are going to learn, is that there are other efforts in other languages, and there's a full implementation, so not wrappers. Right, so there's going to be Python, Fortran, and you're going to hear a little bit about it, future plans. And normally, so people that work only on MATLAB, they will submit something on MATLAB. And then, so we notice we are now tracking that disparity and try to either find developers in-house and see if somebody contributes to that, to at the C++ level to bring that to parity with the MATLAB. Yes. So, so the reason why we don't use sort of translators, I mean, we could, and they are getting very, very good at doing the work, but there are a lot of things that you can take advantage. If you get an experienced C++ programmer, and because we want this for scalability and produce an optimal library, you can do a lot of things. And, so here we have some of the developers, and they can tell you, that it takes a little bit of some iterations looking at how you can optimize the code. And yeah, and so we don't do it automatically. So we want contributions. You put your contributions in the language that you know the best, and then, we track it and we try to find parity in that way. Yeah, well, thanks. Okay. Jared.
That's all right. It's not.
There's another question.
Minimum half hour version and mapping the operating system version versions of CMake, LAPAC, 9.3.
MATLAB is pretty much backwards compatible for all of them because we don't use any of their advanced functionality. I think interp is the only built-in function of theirs that we use. For C++, the library itself has very low requirements. It uses a library called Armadillo. And C++ 11 and that compiles very easily. It's if the examples, we have a bunch of examples that have some more complicated solves in them. And for those examples in C++, we use super LU and eigen. And for those, we have very specific versions that we need. So minimum versions. And they're not like the cutting edge versions. It's too old, Chris.
Pay attention. So they, I was assuming last Linux version for, let's say, the last 3 years or possibly, and then on the back, it's possible that Tahoe before that, before that. But well, there's a lot of failures.
Yeah. For those of you online, yes, those of you online, the question was about failure points and how hard it is to build the Linux or on a Mac OS with this. We have the specific requirements is in the README file in the GitHub, explains what it's been tested on and what the minimum requirements are. And there is a Mac, there's Mac requirements. And it's been tested on most of the Mac OSs and the new chips as well, the new silicon chips, maybe all the way up to M3 Max, all the way up. All right.
Versions into a third-party directory equal to different versions.
Yeah.
Build on the third-party directory.
Yeah, your actual requirements are very low because the CMake itself will pull the appropriate versions into a directory to build the examples for you. All right. So applications of this. One of the applications using the mole library in a large code base is this code that I made. It's the General Curvilinear Coastal Ocean Model 2. In the CSRC at San Diego State, we had an ocean model that was built with memetics, but very much by hand. And one of my projects was to kind of do the same thing, but make it more modern and use the mole library. So it's a coastal ocean model, but really it's a fluid model, a rigid lid fluid model that solves a Boussinesq non-hydrostatic closed lid Navier-Stokes system of equations. I won't go into all the math, but right, it tracks velocities and scalar values on a fixed domain. The cool thing is that for most of the calculus in this, it uses the mole C++ memetic library. So the divs, the grads, the Laplacians in the equation, most of them are using what's available on the mole GitHub. Now, right, because we have to do some solves, there are some other requirements for this. So mole itself, the C++ library uses Armadillo, which is another library which makes the C++ look kind of like MATLAB. So if you're looking at the MATLAB code and you understand it, you look at the C++ code, it looks very similar because we use Armadillo to, kind of wrap complicated C++ commands and vector commands just for readability. So we leverage the Armadillo library, and for solving, we use SuperLU, which is from Lawrence Berkeley, a sparse system solver. The pressure solve in this uses SuperLU. What's nice too about the library is the library has a bunch of boundary conditions built in, and a lot of those are used in this model on the boundaries themselves, but later on when you have to start discretizing the domain, they come in real handy. The final part that's really nice about what the application here is the grids that are used in ocean modeling are not necessarily uniform. Usually they're very messed up. The middle picture there, right, is the Monterey Bay Canyon, where it's very curvilinear grid. And the coordinate transform to solve equations on that is usually super complicated. But this code leverages the curvilinear operators from the mole library. So not only the curvilinear operators, but specifically there are other functions for calculating the Jacobians, both the determinant and the partial differential transforms that are leveraged in this to do those calculations for me. And while those specific curvilinear operators aren't in the main branch, there is a branch, I think it's called Feach curvilinear, that has the curvilinear operators used here. Where this makes the problem and actually coding the problem really easy is parallelizing it. So the code itself is parallelized using MPI, and it's just domain discretization, where you cut up the grid into a bunch of pieces and then separate them to solve. For the interfaces, when you discretize the grid, there is some kind of overlap that happens, and then you code how to handle that overlap. The actual math, the boundary conditions of the overlaps is handled by the mole library, which is super nice, especially if it's on a curvilinear domain and you're just arbitrarily cutting and you want the pressure to have a Neumann boundary condition. Is really nice not to code that and just trust the mimetic operator to do it for you. So here you can see this has been tested up to 1,200 cores so far. Red line on these is perfect speed up. This is a strong scaling test case. So if you keep the problem size the same and then just use twice as many processors, you should get 2 times speed up. So both of these cases, you get super linear speed up, and it's because of the most of it's because of the SuperLU. It's the regular SuperLU, not the distributed. So it really likes small problem sizes. So as you discretize, the speed up you get from that is a lot. Yeah, so it's I guess is a test case for using the library to make something that works, but it also really cuts down on the amount of work you have to code in for these things. Christos, you are next. Are you?
Yes. Hello, I'm here. I'm with you. Can I share my screen?
Yes, go for your share.
Sorry. I go. Wait. Can you see my screen?
Yes.
Yes. So I will keep it short. I will talk to you about an application I'm working on using the mole library. So we're looking at nonlinear weakly dispersive waves. Very quickly, before I show you directly the equations, the problem, the underlying problem is the propagation of water waves near the coast. Here, for example, you can see 4 pictures of different kinds of waves that we can have in this context. And the equations are standard. We're talking about potential flow, so we are irrotational. The difficulty is that we have a free surface, and here is our problem. The set of equations, let's say the starting point. 2 main characteristics that someone should know about water waves is that they are dispersive. So the phase velocity or the pulsation omega depends on the wave number. And they can also be nonlinear, which means that the phase velocity or omega also depends on the amplitude. So these are, let's say, the 90% of the physics that someone has in this context. But the thing is that this is difficult to solve, so we are deriving model equations. And let's say the most popular one is what we call, what I show you here, which is the Serre-Green-Nagdi model. Here is written for flat bottom. Mu is a parameter that, let's say, quantifies how shallow we are. And if you take it equal to 0, you get the standard nonlinear shallow water equation. So this set of PDEs can be seen, can be understood as an extension of the nonlinear shallow water equations where we introduce dispersive effects. And what we have to pay for it is that we have to solve this PD that you look, you see my cursor, right?
Yes.
Yes, this PD here, which is elliptic. This is, let's say, the additional cost. And you have to do this at every time step. So here I plot the dispersion relation of the model against the blue line, which is the dispersion relation of water waves. And this explains why we call them weakly dispersive, because they don't have the exact dispersion, but they do actually when this parameter goes to 0. In the variable bottom case, which is more difficult, the problem is like that. We can write every operator. I will not explain everything, but what I do is replace every differential operator here by its small discrete counterpart, let's say. The only difficulty that I have to mention is that this operator T that has to be inverted is of the form of the gradient of a divergence and not the standard elliptic divergence of a gradient that leads to the Laplace equation. That was a difficulty that I had to treat. The algorithm is very standard, so it's Runge-Kutta with the additional difficulty that at every time step you have to invert a linear operator. I will not go into the details. One interesting test is what we do here when we solve these kind of things is that we take a solitary wave, which is an exact solution, and using that we can study the convergence of the numerical method. Here, for example, I used up to the 8th order Mole operators, and we get the right, let's say, slope. And here, for example, you can see the energy conservation. So we are in the inviscid case, so everything is conserved. And here also I compare, for example, the yellow line is standard finite differences. And the Mole library with the same order gives better conservation without doing anything in the temporal scheme. So everything is the same, Runge Kuta for both of them. So we already gain just from the fact that we're using a staggered grid, we get some improvement on the conservation. At this part, I show you the reflection on a vertical wall. It's a space-time plot. The difficulty here is the treatment of the boundary condition that works very well without any additional tricks, let's say. And this is another case. This is an experimental, this is a reproduction of an experiment, let's say, where a solitary wave hits a wall, solves because of a plane slope, hits a wall and reflects back. And we have experimental data to compare, and here is the comparison. And in this case, the nonlinearity is 0.1, which is considered a little bit, let's say, moderate. And we also have a more nonlinear case, which I show you here. Again, the solitary wave solves, reflects, and propagates in the opposite direction. And this is the comparison with experimental data, sorry. And what we are looking at here is, this 1, 2, 3 correspond to measuring stations where we know the free surface elevation, we can measure it. And here the interesting thing is that at the third station, let's say, which is very near to wall, we don't get any artifacts from the numerical solution, which is considered an advantage in comparison with other numerical solutions. So that's all I wanted to show. And it's an ongoing study, and hopefully in the next few weeks we'll have more results if you're interested to share with you.
Cool, thank you, Christos. Let's do this one.
Do I stop sharing, or do you have any questions
Yeah,
that
you
I
can
can answer?
stop, but I might just clobber you. Are there any questions?
I'm stopping.
There's two. The question is, what version of the library are you using?
I cannot answer this. I don't remember. I can tell you when I downloaded it, like, I don't know, 3-4 months ago, something like that.
Yeah.
Just noticing the comparison with finite element method. Are there a number of comparisons they get between finite element methods, synthetic discrete operator methods?
The question was, are there comparisons between the finite element method and using mimetic discrete methods? For that
No,
problem?
but it's in the to-do list, let's say. There are DG solutions, there are continuous Galerkin solutions, there are hybrid solutions of this type of problem, and we're in the course of doing some comparisons. But the most solid comparisons that I have done for the moment is with standard high-order finite differences on a non-staggered grid. And the next step is to compare with finite elements. and finite volumes and hybrid. There are usually in this, let's say, literature, people prefer to the hybrid approach where the shallow water part is treated with finite volumes and the dispersive part, that is the elliptic operator, is treated either with finite differences or finite elements. So I'm about to do comparisons with these methods as well.
Right. Thank you. Rashmika, last one.
Christos, could you just share with us, because you don't have, you didn't really know about finite difference, mimetic difference before. How difficult was to learn to use the library?
If you know finite differences and high order finite differences, it's easy. Because you know what you are looking for. I'm talking always about the MATLAB version, right? So if you know that you are dealing with stencils, how periodicity is treated, concerning the boundaries, I had already done work on boundary conditions with standard finite differences, so it was easy to find out what was happening. So in general, it was easy. The version I used didn't have the quadratures, so I had to code them myself. But other than that, if we say that the core are the discrete operators, if you have some standard, let's say, exposure to how finite differences are derived, it's easy to understand how the discrete operators are derived in the library.
Thank you.
Okay, thank you very much. So a survey was conducted of mole users and 8 people responded. So I'm going to go over some of the findings of that survey and some comments that people gave. So of the 8 people that responded, we can try and identify 5 classes of users. So some people are in multiple classes, but basically 7 considered themselves numerical software developers. 4 were library users of mole. 3 were actually contributors to the mole library. 2 labeled themselves as software engineers, and there's 1 theoretical physicist. Now, we were asked, what programming languages do these 8 people use? And 6 of the 8, which was surprising, still using Fortran. 6 are using MATLAB or Octave. And 3 were using Python. 3 use C or C++ or Objective-C, a variant of C. And there were 2 Julia users. We also asked, what operating systems do you primarily use? And the majority, 6, using Mac OS, 2 were Linux users, 2 used Linux on exascale clusters like El Capitan or Perlmutter. You know, Perlmutter is running HPE Cray, and El Capitan uses the TOS operating system based on Red Hat. And there was 1 Windows user. So then we asked, what is your level of satisfaction with the mole GitHub repository? And you can see from these results that almost all of them said it was excellent satisfaction. 1 reported very good, 1 did not answer. And I'll just go through like one of the comments. There were some free form comments allowed. 1 person recommended that we give badges in the README file that identifies what level of development each part of the mole repository is at. So it could be like the level of development of documentation, level of development of like the Python implementation, level of development of the the regression testing framework, something like that. So badges to indicate status of development. Then we asked, what was the satisfaction with the MATLAB or Octave API? And you can see that we got all positive reports, 5 excellent, 1 very good. And one of the freeform comments that was given had to do with the license scheme that MOL is currently using. Currently, we're using the GPL license, and one person wanted to use a more permissive license, in particular the BSD license. So there was an issue regarding the particular license that MOL is covered under. Then we asked, how satisfied are you with the MATLAB Octave documentation? You can see that mostly was good. We got 1 good, 3 very good, 2 excellent. And one of the freeform comments was to incorporate what's called MATLAB live scripts. So MATLAB live scripts is kind of like Jupyter Notebooks environment where you can have text, and embedded within the text you can have live computation. And so it was recommended that we introduce like this MATLAB equivalent of the Jupyter Notebooks framework into the documentation, where we explain to users how to use MATLAB, but actually have some free-form examples that are parameterized. The users can vary the parameters and see MOL compute something while they're reading the documentation. Okay, then we asked, how satisfied are users with the C++ API? And we got 3 very good, 5 didn't answer. And there were no actually comments about the MATLAB C++ API. And there were no comments about the C++ documentation as it stands, but we got as well good, very good reports. The next question was on satisfaction with the build system we're using. So currently, to build the C++ implementation, we use CMake framework. And one person, we got good results, very good, excellent. One person recommended that we migrate away from the CMake framework and instead use the Fortran Package Manager, FPM, which is another build system. So that was one recommendation. Okay. The next question was, how satisfied are people with the regression testing framework? And we got good responses. One person recommended that we use a tool called CodeCov, which automates the identification of tests that we should perform to kind of automate the regression testing framework. Then they were asked, how satisfied are users with our onboarding process? Getting people up to speed using the MOL library. We got good results, as you can see, very good, excellent. One person recommended that we develop a quick start guide. So like another little document that allows people to jump right in, build MOL, and do an example. So that was a good idea. The final question was, how satisfied are people with the user friendliness of MOL? How easy is it to use? And we got good results. One person recommended that we do a little better job with diagnostic reporting, especially when there's staggered grid alignment problems that can trip up some people. When there's data type mismatches, that can have some irritants. People get stumped on that. And finally, here's just some selected comments I included, all positive. People said it was a great code that we've developed, and people are appreciating that we've invested time in developing MOL, and people are looking forward to ongoing developments. Okay. Yes. Yes, sir. Yes, sir.
Oh. Yeah, so the issue of EL versus
BSD. Yeah.
that under consideration. What are the issues there?
Right. So with BSD, it's very permissive in that you can adopt mole and then resell it, so you can develop a company, a for-profit company based on mole and sell it. So I think that's a major issue, right?
Yes.
And we have some concerns about that.
Yeah, so actually it's one of the ongoing conversations that we are having. As I mentioned, that we have those circles. So in the software engineering, we are looking at that the resolving in a more holistic way, that what the right license is. But for now, for the this period, we have not considered changing the license from the GPL to.
It's not just that someone might start a company, but someone might already have a company existing. In the existing software, maybe wants to incorporate more routines, but they don't want to turn their whole software into GPL.
Right. Yeah. Oh, yes.
It is possible if your company is interested in using the library, we can actually grant you a license where we put in a container a product for you. And then you don't have to change anything, but you can use the library. And that's a possibility. But I was actually wanted to ask about when they did the reviews, that was before the parity with C++, right?
Yes.
Okay.
And also regarding the reviews, because we did not send the reviews yet or the opportunity to review to the whole community. What we wanted is that we selected 10 users and people that are experts, that are either collaborators or people that are actively using the library. We wanted to put that up front and present it at this meeting. But something that we're going to mention at the end is that this is now open to anybody that wants to spend time reviewing the library. That's one of the ways that you can contribute by sending us feedback. The invitation was just sent to 10 people for the reviews. Oh, sorry.
Right here. Transition into talking about some new language implementation. Okay, so currently, as people know, we have a MATLAB Octave and a C++ implementing, a new Python implementation, and a Julia implementation, and their implementation. Dr. Damian Rusin is developing a Fortran implementation. About the Python implementation, Python is now a general language that people are using, and develop at a higher level of thematics and algorithms of your problem, linear algebra routines. So Python supports some very rich APIs that allow you to do linear algebra, like NumPy, of course. And the Python implementations I'm going to talk about next, use NumPy and for implementing vector, vector matrix, matrix operations. And we use the SciPy core library, which is has a lot of solvers built in, LU decomposition, other solvers. So using NumPy and SciPy together with implementations of the operators in Python will bring mole to Python developers. And you saw from one of the previous slides that majority of the people are using Python already. Now, there's actually been a lot of work been done previously on developing a Python implementation of mole. And one of the people, Carlos, who's on this Zoom session, is actively developing one. It's the one listed third. Carlos is a student at National University in Lima, Peru. And this implementation is currently being updated. And so what we want to do now is to integrate Carlos's work into the mole repository. That's one of the things we're going to be working on this summer. But there was two other implementations. I have the URLs listed here. One was developed by Roman Neuterman at Niels Bohr Institute. This one has not been worked on for a while. The latest commit was 5 years ago, and actually this implementation does not support NumPy 2.0. So that's one issue. And there's another, not as developed as Carlos's implementation, but some development by a person named Dilip Jain. And he actually is maintaining this implementation, but it's not as extensive as the one Carlos has developed. So you can see here is running the regression test framework, a PyTest regression testing framework with Carlos's implementation. So here's the console output testing the divergence gradient Laplacian operators with his implementation. Very nice. And these are the individual operators that Carlos has developed. So we have 1, 2, and 3D divergence gradient and Laplacian operators implemented in Python. He's also implemented 1, 2, and 3D interpolators, and he's developed 1, 2, and 3D Robin boundary condition operators. So he's done a lot of work here, and we'd like to integrate his development into the SDSU mole repository. Okay, now my colleague will talk about the Julia implementation.
Hi, everyone. My name is Valeria Barra, and I'm an assistant professor here at SDSU. Today, I'm going to talk briefly about the Julia implementation for mole. That's the name of the package is mole.jl. As a Julia convention, packages are named with the .jl extension, although it's not really strictly necessary. So for those of you who are not familiar with Julia, it's a newer programming language. I say newer now because it's actually turning 13 this year. So it's been around for a little over a decade now. And I know some people might get really, really passionate about the programming languages that they like or dislike. But I like to say that Julia is like MATLAB done right. So please don't get offended if you're a MATLAB user. I used to be as a grad student myself, but then more recently, I'm a Julia convert. And Julia is open source as Python, and MATLAB is a high-level dynamic programming language. So it has like an interpreter. And some of its unique features is that Julia uses just-in-time compilation, JIT compilation, so that it can translate human-readable code into machine-level code on the fly. For this reason, it actually can combine some performance optimality with like user friendliness of high-level languages. So in one sense, it sits in between like performant languages, like compiled languages like C and Fortran, but it has the user friendliness and feel of a high-level dynamic language like Python and MATLAB. So in some sense, it can represent like the best of both worlds. There are operational code that practitioners use in Julia that are like from some large projects that they have proven performance. So if some people are interested specifically in the applications like geosciences applications like earth science modeling, ocean modeling, there are some nice examples of operational code that use Julia at scale on both GPUs and CPUs, just with native Julia kernels. So you don't really need a lot of different layers. So how the mole.jl development started? It was actually started by student projects. The first project was authored by Mark, and he's sitting here in the audience. So thank you for starting our very first skeleton of the Julia implementation for mole. So Mark started with some 1D operators like gradient, divergence, and Laplacian. And then we later added some more flexibility and modularization in the library. So Julia allows for a very easy modularity of code to resemble like some features from other, like say, object-oriented languages. So we later modularized the package, and now currently there are student projects that are also contributing towards adding 2D operators and boundary conditions, and also adding interpolator operators that are used to combine and compose different operators. We also have an initial draft of the documentations, the Julia docs. Primarily, all Julia packages would use a package that is called documenter.jl to create this nice looking HTML-friendly documentation site. We have it, it's just not publicly posted as our other main package documentation site is on Read the Docs, but we will link this soon. And some recent developments, and for Outlook, we are actually going to present for the very first time, mol.jl at the Julia Global Conference this summer. So JuliaCon Global 2026, which will be held in Mainz, Germany. So I really, truly appreciate all of the students' developments and efforts towards this package. And of course, it's the newest of the MOL implementation, so it's still behind in terms of capability and parity with the other languages, but hopefully we will catch up soon. Are there any questions regarding this part? No? Okay. Then I think I'm gonna talk about the strategic plans next. Oh, yes?
Yes. Can we ask questions about the language?
Of course.
Your language? Yes.
I thought there were no questions, but
I do have. So the first one is for Chris. So when I noticed that the way that the Python is being developed, you had I know that implementation is from Carlos, and that the operators were sort of mimicking the sort of like more the MATLAB way, very right. But if we go like thinking of the functional overloading and things that, properties that Python has, are you thinking or leaning on that direction, or are you going to continue sort of?
No, we can implement more of an object-oriented approach where we develop classes and then allow derivations and use operator overloading and other capabilities of languages, polymorphism, and things like that.
Okay, great, thanks. Any other questions? No? Okay, thank you, Valeria. Sorry.
yeah, absolutely. And just to follow up on your question, Julia allows for the same for like operator overloading. So it truly resembles a lot of the features of object-oriented languages. And it uses what it's called dynamic multiple dispatch. So all functions are compiled the first time that they are encountered by the compiler, and then any subsequent times it will just be used on the fly. So that's also part of the why it can achieve like high performance for the part of the JIT compilation features in Julia. And the multiple dispatch dispatches different versions of a function based on the type and number of arguments. So that's a very nice, neat feature of Julia. Okay, so I didn't see any questions online from Zoom, so let's move on to the next section, which is on the strategic plans. So yes, there are a lot of enhancements going on right now in MOL. some future directions that we are going to take, or we are already undertaking, is more general boundary condition treatments, allowing for curvilinear geometries and more robust curl operators, but also the flexibility and generality of the boundary conditions. For instance, it's reflected from some recent work from our colleague Miguel, who generalized the mixed type of boundary condition that before was a little bit too inflexible in a way that it did not really allow to specify different types of boundary conditions on the different ends of the domain. So this is much more flexible now, and the new version of the boundary conditions is gonna replace, we're gonna deprecate the old Robin boundary condition soon. Also, we continue to bring the different language implementations at parity. So in terms of functionality, but also there is a lot of student contributions in terms of bringing examples at parity, because there are, at this time, there are way more examples in the original MATLAB Octave implementation than there are in the newer language implementation. So this was a great effort from a lot of students here. And also, we want to formalize some of the methods to evaluate the effectiveness of the mole operators, focusing on accuracy, algorithmic complexity, and time to solution across different computational platforms. Also, I want to add, as others have asked and mentioned earlier, we're always constantly planning and considering doing formal comparisons with other numerical methods, some that are like more established or considered like the industry standards, like finite element methods, for instance. And we want to showcase examples where the mimetic operators are like truly given an advantage or are superior. We also want to add more capabilities for coupling of multiphysics problems. And yes, also support integrations with third-party software. There's also some risk analysis and security plan that we are establishing. So currently the focus is like GitHub source code repository and packaged software distributions. We want to be more rigorous about addressing software vulnerabilities. And we are actually planning on submitting a proposal early next year for an NSF SAFE OSE program. So that will focus and hopefully will get us support for funding our efforts towards having a more robust, safe, and secure software for mole. Are there any other questions? I think this was the end of my part. And I'm now passing the baton to Jose. Yes. Thank you all.
Hello. Well, basically, coming back to the beginning, which is basically the focus on the community. For the community engagement, we want to increase, the awareness and interest in the library, as well as in recruiting new developers. And this is one of the objectives of this type of meeting, of the users groups. The idea is to start keep increasing and getting people the opportunity to contribute. So we need to work with existing mole user base on exploring other areas of applicability. So as you saw here, two very good applications, which are very hard, but we know there are people doing applications. We just need to get them up to more exposure and being able to showcase those in the web page that we are developing for the library. Short courses and tutorials. We do have a tutorial coming up on May 12th, and we want to publish more related work. As one of the things is, for example, like we are basically focusing in when you solve a problem, you write the code using the library. And that is actually the best way to showcase the intuitiveness, reliability, robustness of the MOL library for solving complicated problems. And track publication from all users. It's important that when you use the library, you actually cite a reference the library. We actually have, I guess one of the best one is the JAWS paper that we have. That is basically one way to cite, because that is one way to get recognition, the library get recognition of their use. And basically, we're gonna be sending periodic related updates to our mailing list. So we already have quite a few people in our mailing list, more than 100, but I hope that it will continue to increase as we continue to work. This is supposed to be me? Okay. So we went working in identifying, engage, and support users and partners. Create more on hand-on tutorials, which is basically one suggestion by one of the reviewers. I consider that similar, like a quick jump start that you can, because there is a lot of people who don't need to read all that to really get going. But also hands-on tutorials where people can, after a relatively brief presentation, they can just work in solving problems. So we have also in mind doing hackathons and different things, events of that type. So which we are going to be looking for industry sponsors to provide awards for the winners of those hackathons. Maintain and periodically review the governance documents to support all the stakeholders. Maintain and review web-based onboarding documentation with a clear code of conduct. Contribute to guidelines, submission templates, and an auto sheet policy to provide credit to all the contributors, that's very important that your work is being recognized. And recruit peer reviewers for the MOL library. We welcome info from the MOL community through moluse.org, which is our open source repository, address domain actually for the library. And we will want to also input from the GitHub repository. And of course, a thriving community is essential to success of the MOL and sustainability. So you're all welcome, and we thank you everybody for your contribution so far, and we hope that you can keep on contributing.
Okay, thank you. So we come back also to the question of sustainability in terms of our plans. So for the MOL OSC, so you have seen sort of, where do we started? Sort of like asking the question, what do you really need for MOL? Now for the future, what we're looking at is, increase the number of areas where the library is being updated. That also not only, give us more coverage in the computational science domain, but also we learn a lot from how people want to use the library. One of the things that we didn't mention, but all these OSCs, you create a library. The minute that is in the hands of somebody else using the library, you don't know exactly how they are going to use it or for what they are going to use it. So we don't have coverage in that space. So the sustainability is really interesting for us to also learn on how people are effectively using the library. Succession plans. So a lot of what you heard, and I don't know if you saw, like for instance, the Python, the Julia developments, the C++, even the MATLAB Octave, all these APIs are being developed in a distributed way. And because we want to offer reliability, we want to tell people if you're using the library, we always have coverage. That functionality is going to be available when you need it. So if that developer stops using the library, we need to have a succession plan, and how are we going to cover that particular functionality? And, and it's because we are looking at parity across languages, then we have to also work on that. Metrics to evaluate not only the library, so we have the test, we have the exercises, but peer reviewers, it's a good way to do it. So we want to hear from the whole community, but it's always good to hear from people that have a lot of expertise developing numerical libraries or have been developing a lot of computational sciences code, and they could evaluate independently the library. So one of the things that we're going to be looking at is to work with this E4S, which is a group of numerical libraries, also performance tools, and they have several high-performance utilities incorporated in that. The interest is that they create these frameworks that are that really offer portability and scalability, guarantee portability and scalability. So being a member of that sort of also help us with the interoperability across different versions of the software, which is something that is very hard to address and maintain. So we're going to try to take advantage of what this group is doing. So, and as I mentioned, we are going to continue asking the community to send those contributions and keep contributing. And, and one of the ways also that we would like to hear and get feedback is if you go to the GitHub and want to start a conversation, just to start one of the GitHub conversations, something that you don't see in the library or that you would like to see in the library. That's a good point, because you will hear not only from the MOL leadership team, but from other MOL developers, and that will make a more robust, help us make a more robust decision. And of course, all of this also talks about the MOL financial sustainability. So we are now being funded mostly by state and national funding agencies. In the future, we are looking to explore more commercial sources of funding, and that also can help us leverage some of the tasks that you have heard that we have currently ongoing, but also what we need the future of the library to be. And with that, so that's where 2026 to 2027, when we have our second MUG meeting, we hope to give you a new update with new plans. But this is so. Are there any questions or things that you haven't seen from the present and where we are going that you would like us to prioritize? This will be a good point to talk about. Yes.
This one, suppose you have collaborator at another academic institution, they're not, would be another application area, and want to get funding, support application all for use in some other particular area where this other academic institution, not SDSU, is providing data. I would think grant funding of some sort. Say you have two institutions. Are there precedents for that? Or are there special kinds of grants where more than one institution is involved?
Yes. Actually, we do have pending. We submitted a proposal, and these are 3 institutions, UCSD, UCI, and San Diego State, for extending the mimetic methods for computational electromagnetics problems.
Is that a California based?
That is NSF. NSF has something collaborative proposals that when you can involve, doesn't have to be all from California, but in this particular case, the three are from California, but that exists. And for example, we also are submitting a proposal for Genesis, which is a new initiative by the Department of Energy. And we're submitting a proposal. In this particular case, is San Diego State, and the partner is Lawrence Berkeley Lab. So that's precedent, not just for library, for anything. And everything that I participate, the library is involved. So
let's say you have, San Diego State, University of Rochester, what I'm thinking of in particular. NSF would be.
yeah, that's in the NSF has something called collaborative proposals. One advantage, by the way, of that is that every university submit their own budget, and this is much easier versus if you have a sub award, that is a pain because then there is a double. No. That is not the main issue. The problem is that in the collaborative proposal, it's a lead always. So there's a lead institution, and the other one, so it doesn't matter. But in a sub award, which we have done, then we get the grant, and they have to do a subcontract to the other institution, and that is more expensive for us. Okay, so if we do a collaborative proposal, it doesn't cost anything extra because everyone has their own budget and all the stuff. So, but that precedent exists.
Mainly NSF.
No, in DOE, I mean, I'm just giving you an example. You said president, I give you one. Actually, two.
Yeah, but if you have two academic institutions, not a national lab.
I gave you the one that we're pending and hoping to get between 3 universities in California.
Yeah, I think that's a very good point because it sort of talks about the community, from the point of view we think of people wearing different hats. Now you have the users that mostly use the library, and sometimes we don't hear and we don't know who they're using. And I think that when part of the community, the collaborators are the people that that you have a closer collaboration, and the products of what gets capitalized in mall or in their own libraries, it varies. No, there's not a strict rule on how to engage that. And I think that's why you sort of have either a memorandum of understanding, what the agreement is, or the grant that funds that collaboration. And then you have the developers, that we do know because they engage through the mall infrastructure, and we are aware of what their developments and what they are doing and contributing. All right. So next we have an open floor, where we want to hear, from you. And because we only have a few 50 minutes left of this meeting, there are other opportunities. And as Professor Castillo mentioned, we do want to thank a number of people. I apologize for the names that are in blue. I left them, and they were supposed to be in the same font color. But thank you to all contributors, the ones that are online and present in this room. We will not be, in version at the eve of version 1.2 without all your software contributions and make the library stronger. It makes us really focus on the work and supporting more users, and that's very important. So here, we can open in the floor, and people that are online, you can send us comments through chat, or you can raise your hand if you have experience something with the library or ideas that we should incorporate in the library. And then there are other opportunities, and it's if you go to the mall, as I mentioned, to GitHub and start a conversation. And also at the end of today, you're going to get an email where there are two possibilities that you can also use online through the mall OSC website, where you can provide feedback if you just want to write something, whether about the bug, the first mug. We would like to hear, what is your opinion, what things you were expecting that we did not cover and you would like to see it in future mall meetings. We also there was a lot of information. We talk about, the mall governance. There are a lot of documents that, we did not cover in detail, or interfaces. You heard a lot about the languages that we are focusing, and maybe you want to contribute to that. And also now the same review form that the selected 10 people that we asked for review and 8 responded to that is available. So you can also do a full review of the library, and that's a way that we could interact, and you will receive those links after the meeting. But for now, if there are any questions, online or in the room.